It's the day of the SAT. You've been training your whole life for this test. You start the English section and you're flying. You're thanking Khan Academy and your English teachers for all these tips they gave you. Soon you finish. You get that perfect 800 score and you start thinking about everything. You start thinking about which Ivy you're going to, how much money you're going to earn in the future. Your life is perfect, man. But then, let's see. In the given equation, a and b are constants, positive constants. The product of solutions to the given equation is KAB, where k is a constant, just like a and b. What is the value of k? So two things catch my eye when I see this equation. First off, we have this really big and complicated equation that could probably scare a lot of people taking the SAT. And secondly, I see the product of solutions to the given equation is equal to KAB. What does that mean? So a solution is when the graph intersects the x-axis at whatever point. So it could be over here, for example. And we can call, this will be our solutions. We can call these points x1 and x2. These are what these are typically called, but you can call them anything. And specifically, it says the product of solutions, that being our x1 and x2, the product, is equal to KAB. Now, here's the thing. We have an equation to solve for k, but we don't know k, a, b, or our roots. That's a problem. So you could think of this as for each thing you have to solve for, you need that amount of equations. So for example, if I were solving for x and y, I would need two equations. I can't solve for x and y with just one equation. It wouldn't make sense. So over here, you would technically need bare minimum 3 or 5 equations to actually solve this. So off the bat, even though this could be valid, we don't know x1 and x2, nor do we know a and b. So this wouldn't work. But what about another algebra 2 concept? The product of solutions is equal to x1 times x2, but it's also equal to c over a. Now, c over a is equal to x1 times x2, but what is c over a? Well, we know that in a quadratic, ax squared plus bx plus c represents this, where a is our term with an x squared, always. B is our term or terms with an x, and c is our term that's a constant, has no x, if you want to think of it like that. So what do I see here? When I'm matching these equations up, 57x squared is our a value. 57b plus a times x would be our b value, but we don't need that. And a over b, or sorry, a times b would be our c value. So now we actually have some values to work with. We don't just have unknown numbers. So after rearranging the c over a and plugging in the values that we know, it would give us a over b is equal to 57, which this part of the solutions is also equal to KAB. Now, where did I get KAB if x1 times x2 is equal to c over a? Well, we know over here that x1 times x2 is equal to KAB, so whichever value you plug into this equation, it wouldn't change the outcome. So, now we have a little situation. We have AB over 57 and K over AB, but our algebra sucks. But don't worry. Obviously, we want to solve for K. So K is not moving from here, and we would divide by AB. AB gets rid of this and this. And now we're stuck with AB over 57 over AB is equal to K. Now, what is this? This looks like a weird fraction. And realistically, this is where a lot of people get mixed up from. Here's the thing. AB, no matter what, any number, 2, 3, 4, whatever, they're always all over 1. There's always this imaginary 1 everywhere. It's under them. It's to the left of them, for example. It's everywhere. So AB, we could say, is over 1. Well, this just made it more complicated, no? K is equal to whatever this is. So to get rid of AB over 1, we will multiply by the reciprocal. What's the reciprocal? Reciprocal, and for example, let's say 2 over 3. Reciprocal is just the value flipped. Meaning that 2 over 3 would just be 3 over 2. This will be the reciprocal value, giving us this. So if we use this same logic over here, K is equal to, multiplying by the reciprocal, AB over 57 times 1 over AB. Again, how do I get this? You could think of AB over 1 as kind of like, I like to think of it as like it's flipping in a way. So 1 in this fraction is going to go on top. And the top of this fraction, which is AB, is going to go at the bottom. Like how the reciprocal would say, the values will flip. So now we have K is equal to AB times 1 times 57 over AB. Now if you haven't seen already, we can cancel out our ABs off the bat, but I'll show you why in a second. Because sometimes these things aren't intuitive to other people, so let's multiply this across. So K is equal to AB times 1, which will give us AB. 57 times AB, these are constants, so they don't go together, so 57 AB. And now we have AB on top and AB on the bottom. So if we have AB in both locations, we could take from both locations to simplify this. So simplifying it by canceling out AB and AB would give us K is equal to 1 over 57. And that's our answer. A circle has a center G and points M and N lie on the circle. So let's draw this out real quick. Center at G and points M and N lie on the circle. Line segments MH and NH are tangent to the circle at points M and N respectively. So how does this look like? Tangent is when it touches the circle only one point. So it's not going through the circle, it's not going around the circle, just passing through one point and one point specifically only from the circle. So it looks something like this. And we have another line tangent at MH as well. And connecting this would be point H to make this all true. Now we also know our radius is 150. And we know that quadrilateral GMHN is 3500. That's about all we need to know. So now we need to find what points G and H is. What's the distance between these 2 points? Well, we know that because for MH and NH to be tangent and form at H, they would have to have the same distance and the same length. So we could say that MH is equal to NH. So when we plug this into the equation, let's call NH x, for example, then MH would also have to be no matter what x. So if a quadrilateral, which is a shape of 4 sides, as we can see, we also have 4 sides here. 1, 2, 3, 4. If a quadrilateral is 3,500 millimeters, so 3,500 millimeters, and it's equal to the sides all four of these sides. So 150 plus 150 plus x. Now we can solve for x. So 3500, after simplifying this will be 300 plus 2x, and subtracting 300 on both sides will give you 2x is equal to 3200, and dividing by 2 would give 1600 as x. Now, here's a common mistake. People will see 1600 and just assume that, oh, answer B 1600 is right. But no, this is the distance between NH, so N and H, or M and H. But we're not asked to solve for that. As you can see, we're asked to solve for G and H, which is this right here. So how can you solve for that? So let's simplify this here. Now that we know that x is 1600, we can see a little pattern forming. So this right here is a right angle. And now, when we have a right triangle, because a right triangle must have a right angle, we can set up a little Pythagorean theorem between 1600 and 150 to solve for G and H. Now, while doing this, if you don't remember the Pythagorean theorem, that's totally fine. It's a squared plus b squared is equal to c squared. So 1600 squared plus 150 squared. A and B are the legs of the hypotenuse. Of the triangle. The hypotenuse is the longest side no matter what. So 1600 squared plus 150 squared is equal to GH squared. And to solve for G and H, we're going to have to square root all this. So this will simplify to GH is equal to square root of 1600 squared plus 150 squared. And after solving all this and simplifying the square root, you would get that GH is equal to 1607, which would be C. Okay, next question. The perimeter of a right isosceles triangle is 256 plus 256 root 2. What is the length of the hypotenuse? Well, if you guys don't know what the hypotenuse is, first off, you should probably go back to geometry class, but the hypotenuse is the longest length, like in length. So I just think of it as like the longest side, but anyways, the hypotenuse has to be the longest side to be the hypotenuse, if that makes sense for you. But let's draw our triangle first off. So they said a right isosceles triangle, so right side and isosceles. What does isosceles mean? So isosceles means that a triangle has two equal sides. So what if I said this side and this side are equal? Well, then that's wrong, because the hypotenuse has to be the longest side. If this side and this side are equal to it, then it isn't the hypotenuse anymore, because it isn't just the singular longest side. So this side and this side must be equal to each other just to keep it as a right isosceles triangle. But what is this? All we know is that the perimeter is equal to 256 plus 256 root 2. So how are we supposed to solve this? We don't know this side, we don't know this side, we don't know this side. Well, if you look at your SAT review sheet, you will see these two little triangles. And these triangles are called special right triangles. I'm going to just say this for short. So, in one of them, you would see an x, 2x, x, and an x root 3. This one, if you look closely, you would see it has 30 degrees, 90 degrees, and 60 degrees. So you would call this one a 30, 60, 90 triangle. And the second one is a triangle that looks like this. Boom, boom, x, root 2, x, and x. This one's called a 45, 45, and a 90 triangle. Well, we have these two triangles, but how do we know how to use them? So, like we knew previously, this side and this side are both equal to each other. In our first 30, 60, 90 triangle, this side and this side aren't equal to each other. Therefore, this triangle isn't an isosceles triangle. But this triangle, we see that this side and this side are equal. So we can safely say that this is a special right triangle that fits the scenario of an isosceles triangle. So, by combining like terms, we could say that the perimeter for this triangle is just P is equal to x plus x plus x root 2. And we also know, because this triangle and this triangle are the same thing, they each have the same proportions, they're each a special right triangle that's 45, 45, 90, because each side is x. So we could say that this triangle, the perimeter would also be 256 plus 256 root 2. If you like to think about it more deeper, you could rewrite the triangle so it's something like this. X root 2, x and x, and these all equal something. Let's say equals b. But we don't know each specific side of this. Like, we could solve for the hypotenuse, for example, if we were given this side was also 100. So then the hypotenuse would just be 100 times 100 divided by root 2. But we don't know this. So we can't theoretically solve by just setting up variable equations. But instead, because we both have two perimeter equations, perimeter 1 and perimeter 2 equations, then we could then set each other equal to each other. So x plus x root 2 is equal to 256 plus 256 root 2. Now, this does look like some crazy algebra, but why do the algebra when Desmos can just do it for you? So when you plug in Desmos, when you plug in this whole equation just like this into Desmos, you can zoom out, and then you get that x is equal to 181. So then 181 should be our answer, right? No, because if you look back to it, we're solving for the hypotenuse. The hypotenuse is x times 180 times root 2. So the hypotenuse, which is equal to x root 2, after we plug in x, because now we know x is 181, it would be 181 times root 2, which would give you approximately 256. In the figure shown, AB, which is this side, is equal to root 185. So root 185. And AC, which is this side over here, is equal to 4. CE, over here, is equal to 10 units. What is the area in square units of triangle ADE? So this triangle over here. Well, first off, I like to find out every side possible before we get into any assumptions. So right now we have a right triangle and we have a missing side. So if you haven't noticed already, we could do Pythagorean theorem on this. So a squared plus b squared is equal to c squared, where 185 is our hypotenuse and 4 is our b. Now 4 could also be our a, so you don't gotta worry about that. But 4 can never be our c in this case. So a squared plus 4 squared is equal to root 185 squared. And we all know that
a square root squared would cancel out the square root. So we're left with a squared plus 16, because of 4 squared, is equal to 185. Subtracting 16 on both sides would give you a squared is equal to 169. And squaring both sides would give you a is equal to 13. So we have BC as 13. Now what can we do? Well, from geometry class again, we can figure out that these two, this big triangle and this little triangle, are similar triangles. You could think of it because this little triangle is inside this huge triangle, right? So because these triangles are similar, we can do something called corresponding sides. So the smaller side over the big side. Now I'll show you what this means. So because these triangles are similar, you could think of it as like this small triangle and big triangle and big side. They're like cousins or brothers. So for example, this 4, right, is the small side all over the big side, which isn't 10. That's there to confuse you. It's 4 plus 10, because CE isn't a triangle. As you see, this is a quadrilateral, and plus this little triangle isn't inside of this quadrilateral. So because this little triangle is inside of this big triangle, then we could do 4 plus 10 for the bigger side, which is 14. And we could do the same thing, if you're getting the hint, of 13, because of this corresponding side, with this big brother, which here would be DE, which would be x. So now we have a value to solve for DE. But why are we solving for DE? We know that we want to find the area of AD and E. So we know that triangle is 1/2 base, which in this case will be 4 plus 10, which is 14, plus x. Because we don't know x, we don't have anything to find it, like how we were given CE is 10. So we're doing this to find what side DE equals. So by setting 4 over 14 equal to the smaller side of 13 over x, the bigger side, we cross multiply and we get 4x is equal to 182, and dividing by 4 would give us x is equal to 45.5. So now we have, which is equal to DE, sorry. So now we have all of our sides that we need. So 1/2, 14, and 45.5 would give you that the area of ADE is equal to 308.5. Okay, last question. A rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. So how would this look like? Well, we would have a circle like so, and then a rectangle will be inscribed in a circle. That means each corner of that rectangle, like so, is touching the circumference of the circle, which, if we didn't know, the circumference is this whole little ring part. Okay, now it says the diagonal of the circle, of the rectangle, is twice the length of the shortest side of the rectangle. The area of the rectangle is 1089 root 3. What is the length in units? What is the length in units of the diameter of the circle? So we know that the area of a rectangle is length times width, which is 1089 root 3. And we also know that the diagonal of the rectangle is 2x, which is 2 times the shortest side, which will make this side x. And now we see another pattern again, like we saw in the previous question. This is a special right triangle, because this side, this 2x, goes here, and this x on the wall also goes here. And by looking at our SAT formula sheet, we will see that the next part, or the next side of this triangle, would be x root 3. Because it isn't hinted, because we don't know the degrees, but if we get one side and another side, then we, like, by the law of Pythagorean theorem, we could also find this side. So now we know that the bottom or the width of the rectangle is x root 3. So then, knowing this, we could plug in our length, which is this, with our width, which is this. So then we get x root 3, actually apologies, this is our length, x, and x root 3 as our width is equal to 1089 root 3. And then when you solve for x, you would get that x is equal to 33. But we're not solving for that, we're solving for the diameter of the circle. But if you look closely, this diagonal is the diameter. Because if we know from geometry class, the radius is halfway, is from the center to the circumference of the circle. And the diameter is always equal to 2r. And the diameter always covers twice the radius, which this is doing just that. So we could say that instead of 2r, we could say that is 2x is equal to the diameter of the circle. So then by plugging in x, which we found as 33, we find out the diameter is equal to 66. And that gives us our answer.